The modern clothing industry depends on speed, consistency, and mass production. However, this system is built on a solution to a problem that existed for thousands of years: the slow and labor-intensive process of sewing. Before the invention of the sewing machine, all clothing was made by hand. Sewing was not just a profession, but a necessity for survival. Early humans used stitched materials to protect themselves from cold weather, environmental conditions, and physical harm. Without sewing, survival in many regions would have been extremely difficult. The earliest evidence of sewing dates back over 20,000 years. Early tools included needles, made from animal bones, and threads created from natural fibers or sinew. These tools allowed humans to create fitted clothing instead of simply wrapping materials around the body. For thousands of years, the method of sewing remained unchanged. Every stitch was done manually, using a needle and thread. This made the process extremely slow. Even simple garments could take several days to complete, while more complex clothing required much longer. As a result, clothing was valuable and often repaired instead of replaced. As populations increased and societies developed, the demand for clothing grew rapidly. However, production methods did not improve at the same pace. This created a clear gap between demand and supply. Sewing also required precision. Each stitch needed consistent tension and spacing. If done incorrectly, the fabric could tear or the seam could fail. This made it difficult to increase production speed without sacrificing quality. The idea of creating a sewing machine began to appear in the 18th century. In 1755, Charles Frederick Wiesenthal patented a needle designed for mechanical use. Later, in 1790, Thomas Saint introduced a design for a sewing machine. However, there is no strong evidence that his design was successfully used. These early attempts showed that the concept was possible, but the technology was not yet advanced enough. Mechanical limitations prevented the creation of a reliable machine. By the early 19th century, the need for a faster method became urgent. Growing populations and expanding trade increased the demand for clothing. The problem was clear, and the foundation for innovation was already in place. The next stage would bring the first working sewing machines and mark the beginning of a major industrial change. By the early 19th century, the need for a practical sewing machine had become increasingly urgent. Previous designs had failed to deliver consistent results, but inventors continued experimenting with new mechanisms and approaches. The goal was no longer theoretical. It was to create a working machine that could replace hand sewing. One of the first major breakthroughs came in 1830, with Bartholomew, a French tailor who developed a functional sewing machine. His design used a single thread and a hooked needle to create a chain stitch. Unlike earlier concepts, his machine actually worked and could produce stitches at a much faster rate than hand sewing. Thimonier's invention was used to produce military uniforms for the French army. This marked the first time a sewing machine was applied in a real production environment. However, the success of his invention created unexpected problems. Traditional tailors feared losing their jobs, as the machine significantly reduced the time required to produce garments. As a result, a group of workers attacked Thimonier's workshop and destroyed many of his machines. This event slowed the spread of his invention and demonstrated the resistance that often follows technological change. Around the same time, inventors in other countries were working on similar ideas. In the United States, Walter Hunt developed a machine in the 1830s that used a different technique known as the lock stitch. This method used 2 threads instead of 1, creating a stronger and more reliable stitch compared to the chain stitch. Although Hunt's design was advanced, he did not patent his invention. As a result, his contribution was largely overlooked at the time, and others would later build upon similar concepts. The development of the lock stitch was a critical step in improving Sewing machine reliability. It allowed seams to remain secure even under stress, making it more suitable for everyday clothing. Despite these advancements, early machines still had limitations. They were often difficult to operate, expensive to produce, and not widely available. Many designs lacked durability and required frequent adjustments. However, the key problem had finally been solved. A machine could successfully replicate the basic process of sewing. This marked the transition from experimental designs to functional technology. By the 1840s, the foundation of the modern sewing machine had been established. The next stage would focus on refining these designs, improving efficiency, and making the machines accessible to a larger market. This period also set the stage for intense competition between inventors. As new improvements began to emerge, and the potential of the sewing machine became clear. By the 1840s, the sewing machine had moved beyond experimentation and entered a phase of rapid development. Multiple inventors were working on improving existing designs, and the focus shifted toward efficiency, durability, and commercial use. This period marked the beginning of intense competition, where control over patents became as important as the invention itself. One of the most important figures during this time was Elias Howe. In 1846, he received a patent for a sewing machine that used a lock-stitch mechanism. His design included a needle with an eye near the tip and a shuttle system that worked with a second thread. This combination produced a strong and consistent stitch, solving many of the problems found in earlier machines. Howe's invention was a major technical improvement, but it did not achieve immediate commercial success. The machines were expensive and not widely adopted at first. Despite this, his patent would later become extremely valuable as other inventors began using similar mechanisms. At the same time, another key figure entered the industry, Isaac Singer. Singer did not invent the sewing machine from scratch, but he made critical improvements that made it more practical for everyday use. His design included a straight needle, a foot pedal for continuous motion, and a more stable structure. These changes made the machine easier to operate and more suitable for long periods of use. Singer focused not only on design but also on business strategy. He introduced installment payment plans, allowing customers to purchase machines over time. This approach made sewing machines accessible to a much larger audience, especially households and small businesses. However, as Singer's machines became popular, legal conflicts began to emerge. Many of his designs used features that were already patented by others, including Elias Howe. This led to a series of lawsuits over patent rights, as inventors and companies competed for control of the growing market. These legal battles became known as the early sewing machine wars. Instead of focusing only on innovation, companies were now fighting in court to protect their inventions and claim profits. The situation became increasingly complex, with multiple overlapping patents covering different parts of the machine. Despite the conflicts, this competition accelerated progress. New improvements were introduced more rapidly, and machines became more efficient and reliable. By the late 1840s, the sewing machine was no longer a rare invention. It was becoming a practical tool with strong commercial potential. This period laid the foundation for production and set the stage for major industrial growth. The next phase would bring cooperation between competitors and the expansion of sewing machines into factories and homes on a much larger scale. By the early 1850s, the sewing machine industry had entered a period of intense legal conflict. Multiple inventors and companies held patents covering different parts of the machine, including stitching methods, needle design, and fabric movement systems. Instead of a single, complete invention, the sewing machine had become a combination of several patented ideas. As demand for machines increased, so did disputes over intellectual property. manufacturers began filing lawsuits against each other, claiming unauthorized use of patented components. This period became known as the Sewing Machine Wars, where legal battles slowed production and created uncertainty across the industry. At the center of many of these disputes was Elias Howe, whose lock-stitch patent was essential for producing strong and reliable seams. Companies that used similar stitching methods were required to pay royalties, leading to widespread resistance and ongoing court cases. Another major figure, Isaac Singer, continued expanding his business despite these challenges. His company produced practical and user-friendly machines, but like others, it relied on technologies covered by existing patents. This made legal conflict unavoidable. The situation eventually became unsustainable. Continuous lawsuits were costly and slowed innovation. Instead of focusing on improving machines, companies were spending time and resources fighting in court. In 1856, a solution was introduced that changed the industry: the creation of the first major patent pool. Several leading companies, including those associated with Howe and Singer, agreed to combine their patents into a single shared system. This agreement allowed manufacturers to use essential technologies by paying a standardized fee rather than facing multiple lawsuits. This patent pool is often considered one of the first examples of organized intellectual property sharing in industrial history. It reduced legal conflict, encouraged cooperation, and allowed companies to focus on production and innovation instead of litigation. With legal barriers reduced, the sewing machine industry began to expand rapidly. Production increased, costs gradually decreased, and machines became more widely available. Manufacturers could now focus on improving efficiency, durability, and usability. This shift marked a turning point. The sewing machine was no longer limited by legal disputes. It was now positioned for large-scale growth, both in industrial settings and in everyday households. The next phase would see the sewing machine move beyond workshops and factories, becoming a common tool in homes and transforming the way clothing was produced on a global scale. After the major patent conflicts were resolved in the mid-19th century, the sewing machine industry began to grow rapidly. With fewer legal barriers, manufacturers could focus on improving production and expanding their reach. This allowed sewing machines to move from limited use into large-scale industrial environments. Factories quickly adopted sewing machines because they significantly increased production speed. Tasks that once required days of manual labor could now be completed much faster. This made it possible to produce clothing in large quantities, supporting the growing demand in expanding cities. One of the key companies leading this expansion was Singer Corporation. Developed under Isaac Singer, their machines were designed to be durable and suitable for continuous use, making them ideal for factory production. At the same time, sewing machines became more accessible to individuals. Manufacturers introduced installment payment systems, allowing customers to buy machines over time instead of paying the full price up front. This made it possible for many households to own a sewing machine. The growth of sewing machines changed how clothing was produced. Instead of relying on individual tailors, production shifted toward factories. Workers were assigned specific tasks, increasing efficiency and speeding up the overall process. As production increased, clothing became more affordable and widely available. This marked the early development of ready-made garments, reducing the need for custom tailoring. The sewing machine also supported the expansion of trade. Clothing could now be produced in large quantities and distributed to different regions. This helped build the foundation of a global clothing industry. By the late 19th century, sewing machines had become essential in both factories and homes. Their ability to increase speed and reduce cost made them a key part of industrial growth. The next stage would focus on further technological improvements, including more advanced and efficient machine designs. By the late 19th and early 20th centuries, sewing machines had already transformed clothing production. However, the next major improvement came with the introduction of electricity. This shift marked a new phase in efficiency, speed, and usability. Early sewing machines were powered manually, using hand cranks or foot treadle systems. While effective, these methods still depended on human effort. The introduction of electric motors eliminated much of this physical labor, allowing machines to operate at a consistent and much higher speed. With electrification, sewing machines became easier to use and more efficient. Operators no longer needed to focus on powering the machine itself. Instead, they could concentrate fully on guiding the fabric and maintaining stitching accuracy. This significantly increased productivity in both factories and home environments. During this period, companies like Singer Corporation played a major role in upgrading existing designs. Machines were redesigned to integrate electric motors, improved speed control, and more stable internal mechanisms. These upgrades made sewing machines more reliable and suitable for continuous industrial use. As technology improved, sewing machines also became more specialized. Different types of machines were developed for specific tasks such as straight stitching, embroidery, buttonholes, and heavy-duty fabric work. This specialization allowed industry to produce more complex garments with greater precision. The modernization of sewing machines also had a direct impact on the workforce. Production lines became more organized, with workers assigned to specific roles in the manufacturing process. This increased efficiency but also changed the structure of labor in textile industries. At the same time, sewing machines continued to grow in popularity in households. Electric models became more common in homes, especially in urban areas. This allowed individuals to repair and create clothing without relying entirely on professional tailors. The availability of electric sewing machines also encouraged creativity and small-scale clothing production. Many people began using sewing machines for personal projects, contributing to a growing culture of home-based garment creation. By the early to mid-20th century, sewing machines had become standard equipment in both industrial factories and private homes. Their evolution from manual tools to electric devices marked a significant technological shift in everyday life. This stage of development laid the foundation for even more advanced innovations, including automated stitching systems and computerized sewing machines, which would emerge in the following decades. As technology advanced in the late 20th century, sewing machines entered a new phase of development, focused on automation and precision. The goal was no longer just speed, but accuracy, consistency, and programmable control over stitching patterns. Early electric sewing machines improved efficiency, but they still required full manual guidance. The next step was automation. Machines began using mechanical and electronic systems that could repeat stitching patterns with minimal human effort. This reduced human error and improved production quality in factories. Manufacturers such as Singer Corporation introduced machines with advanced controls that allowed users to select predefined stitch patterns. Once selected, the machine could execute these patterns automatically, saving time and increasing productivity in industrial environments. This shift changed factory production systems. Instead of relying only on manual stitching, machines could now handle repetitive tasks with consistent output. This allowed factories to produce more complex designs without increasing labor requirements. By the late 20th century, sewing machines began to include electronic components. Mechanical dials were gradually replaced with digital control panels. Users could adjust stitch length, width, and pattern with much higher precision than before. This made sewing more flexible and efficient. The introduction of computerized sewing machines was another major step. These machines used digital memory to store patterns and reproduce them automatically. Intricate designs, embroidery, and logos could be stitched with high accuracy and repeated consistently across large production batches. In industrial settings, automation led to more structured production lines. Different machines were assigned specific tasks, creating a coordinated system where each step of garment production was optimized for speed and efficiency. This reduced production time and increased output significantly. Home sewing machines also became more advanced during this period. Compact computerized models entered consumer markets, offering features once limited to factories: automatic threading, built-in stitch programs, and digital settings became common in household machines. Despite all these advancements, the basic purpose of sewing machines remained the same: joining fabric efficiently. However, the methods used to achieve this goal evolved from purely mechanical systems to electronically controlled and programmable technology. Automation also reduced the level of skill required to operate sewing machines. Tasks that once required years of training could now be performed with basic instruction, making sewing machines accessible to a wider range of users. By the end of the 20th century, sewing machines had fully transitioned into electronic and computerized systems. This transformation marked a major step in industrial evolution and set the foundation for more advanced smart manufacturing technologies. The sewing machine is one of the few inventions that quietly transformed everyday life across the entire world. While it may seem like a simple tool, its impact on industry, economy, and society is enormous. From clothing production to global trade systems, its influence is deeply embedded in modern civilization. Before sewing machines, clothing was slow and expensive to produce. Most garments were made individually, requiring long hours of skilled labor. This limited access to clothing and kept production volumes low. The introduction of sewing machines changed this system completely by increasing speed and reducing production costs. As machines became more advanced, they allowed factories to produce large quantities of clothing in a short time. This shift supported the growth of the textile industry and contributed to the rise of industrial economies. Clothing became more accessible to the general population, no longer limited to wealthier groups. The influence of sewing machines also extended into employment and labor systems. New factory-based jobs were created, and production processes became more organized and specialized. Workers focused on specific tasks within a larger system, increasing efficiency but also changing traditional forms of craftsmanship. Global trade expanded alongside industrial production. Countries began specializing in different parts of clothing manufacturing, creating international supply chains. Raw materials, production, and distribution became connected across continents, forming the foundation of today's global fashion industry. Companies such as Singer Corporation played a major role in spreading sewing machine technology worldwide. Their machines helped standardize production methods and made sewing technology accessible across both industrial and domestic markets. In households, sewing machines also changed daily life. People could repair clothing, create garments, and develop small-scale tailoring businesses. This increased independence and supported local entrepreneurship in many regions. Over time, sewing machines became more than just industrial tools. They became symbols of technological progress, representing how simple mechanical ideas can evolve into systems that shape entire industries. Today, even with advanced automation and digital manufacturing, the core function of sewing machines remains unchanged. They continue to connect fabric, support fashion, production, and power one of the largest industries in the world. From ancient bone needles to smart computerized systems, the journey of the sewing machine reflects a long history of human innovation. It is a story of problem-solving, continuous improvement, and global transformation driven by a single simple idea: stitching fabric together.